Alright, let's look at an example for homework 15, problem number 3, part D. Alright, so we want to find the inverse Laplace transform of 9 minus s over 4 minus s squared. Alright, so we need to think of a function whose Laplace transform is similar to this guy. Alright, then if you remember that the Laplace transform of hyperbolic cosine of kt is equal to s over s squared minus k squared, right? And also Laplace transform of hyperbolic sine of kt is equal to k over k squared minus k s squared minus k squared. Right? So let's try to fit this form. Alright, first we have let's see, 2 squared minus s squared. So I want to just multiply top and bottom by -1 to get this. So I'm gonna multiply top and bottom by -1. So multiply by -1 and a -1 here. Right? Then you will get right, inverse Laplace transform, right, of right, s minus 9 over right s squared minus, I'm gonna write it as write 4 as 2 squared, right? Then we can split, right? So this is going to inverse Laplace transform of right s over s squared minus 2 squared, right? And then you have minus 9 over right s squared minus 2 squared, right? So we would like to have 2, so I'm gonna put 2 here, then divide by 2 so that we don't change the quantity, right? Then you can see that here, if you take the Laplace inverse Laplace transform of s over s squared minus 2 squared would be cotangent, not cotangent, sorry, hyperbolic cosine of 2t. Then you have a -9 over 2. This is hyperbolic sine of 2t, right? So this is the inverse Laplace transform of this function right there, right? That's it. I hope that this was clear.